A lot is changing in the infrastructure space, especially in the public cloud arena. And one of the biggest topics that we are spending a lot of time on is availability. As you might guess, Salesforce is a mission critical service. Even a blip in terms of a downtime has an impact on day-to-day lives of people. People do finances, they do insurance, they do emergency services, they do a
Yeah.
lot of really critical things on top of Salesforce, the platform. The responsibility as the infrastructure engineering team that we have is to design and architect and build systems for scale, availability, and resilience. It can't be a bolt on. We have to think right from the point when somebody starts a design document, even before a line of code is written, and ask the questions of how do we make sure this is a highly available, resilient architecture. And within that space, one of the concepts that we care really deeply about is what we call the radius of impact. Some people also refer to it as blast radius. What that really means is that when you have a failure in your infrastructure, how does your architecture gracefully handle that failure? How much of your surface area is impacted by it? How many customers experience it? How do you measure it? How do you observe it? How do you recover from it? That's really a large activity for us. We've spent a lot of time and effort and dollars in
Yeah.
making our infrastructure truly, truly available. And that's a topic that's really close to our hearts this year.
In your architecture, a system, whatever, is down, how do you figure out the impact of that particular component? Are there tools? What methods, what techniques do you use? When you're architecting, do you say, all right, as you're putting components together, okay, this is the, if this goes down, this is, I mean, how do you wrap your head around that kind of impact?
That's a very hard question to get right in production at scale. And that's because, you have to start thinking about it right from the moment you do the design of the system. When you're doing your architecture, you have to ask, okay, what are my hard dependencies and what are my soft dependencies? How can they go down? If I'm building a system that needs to be a 4 nines system,
Hmm.
I cannot obviously be dependent on a 3.5 nines system or a 3 nines system. And what makes it harder is that some of the off-the-shelf services, like for example, if you go to a managed service from a public cloud platform, what they advertise to you is not the achieved
Yeah,
availability. What they advertise to you is the availability after which they'll compensate you. That is not what you want as a
that's right.
builder. You are going to give me back some of my money, but my
But I
customers are
don't
already
care.
angry.
Yeah, yeah, yeah.
So it's a very tricky problem, and you start by asking the dependency questions right at the design phase. And
Hmm.
then as you go through the life cycle of the software, you have to be very, very keen on making sure you have cellularity, which means that
Mm.
let's say you are a geographically distributed service, your customers only rely on one or a pair of regions. Or let's say you have persistence, you have state, you have to make sure that the state is available across cells which have different failure modes. Perhaps they're isolated by way of regions or availability zones and so on and so forth. So cellularity becomes really, really important. And
Mm.
then when it comes to runtime, you have to measure your dependencies. Do not think that just because your customers did not experience a problem, you are good, because you might
Yeah,
just be lucky.
yeah.
That blip that happened at midnight when customers were not really using your system at peak will come back and bite you in peak hours. So the whole life cycle changes when you want to design for.
The blast radius is one great example that we don't spend as much time on. We're spending a lot of time with topics like divestitures, with topics like, what happens if this thing goes down because it's 30-year-old system. We don't know what things it's impacting because everything else is modernized, but this thing isn't. And we have no idea actually how much it wipes out when it goes down because we have, a lot of, kind of dependency on it. And so that's one. And we are looking to bring visibility by way of Ket.io so that you have all those dependency maps visible and readily available that are real time and current, available at all time.